Hello guys, how you doing? In this video, I will explain how I made a multimeter using Arduino and LCD 16 by 2. Here we have a sensor, a current sensor ACS712, and I made a a voltage divider here to measure the voltage using the EDC. And using the ACS712 for current sensing. Okay, I connected the output of this sensor to A1 and the output of the voltage divider to A0. Okay, and there is some connection to the LCD. In the code, we have a library for LCD, liquid crystal, and the configuration pin for A0 and A1. First one for the voltage and the second one for the sensor of the current. The voltage reference is 5 volt, which is the voltage of the Arduino itself, and the EDC resolution is 10 bits, so it's the maximum value is 1023. The sensitivity of this sensor, I got it from the datasheet to be 0.066 volt per current, or 66 millivolt per 66 volt per milliampere. And for this module is I used the 30 amp for this type of module. I used the 30 amp one, but when I tried the codes, I found out that this number isn't very accurate, so I tried to make like a calibration for the sensor, and I found that this is the best value. For the zero current is gonna be 2.5 volt. So when this pin get out 2.5 volt, which that means there is no current passing through this wire. And then there is an equation I made it here to get the current. First we get the analog reading from the pin of A1, and we get this value, and then multiplied by the voltage reference divided by the resolution, so we can get the voltage from the sensor that came out from this pin. Okay, and then we subtract the zero voltage current, which is 2.5 volt, from the voltage we get from this pin. Okay, and then we divide it by the sensitivity, which is here. Okay, so the result of this equation will be the current of that this sensor is sensing. Okay, the voltage, for the voltage I made a multiplier here using voltage I made a voltage divider here connected between those pins or terminals of the battery. Okay, this voltage divider will result if we sense it a 5 volt, the output of this will be 1 volt of this voltage divider. So if the maximum voltage we can measure is 25 volt, because if those terminals is connected to the 25-volt battery, the output of this voltage divider will be a 25 volt. It will be 5 volt, sorry. The output of this bin will be 5 volt. Okay. And here is the equation we use to get the voltage. First, we get the readings from the ADC, and then we get from it the voltage we sensed, and then multiplied by 5 to get the voltage we measure between those pins, those two pins. Okay. And then I use serial print to print the voltage and the current and the power on a serial monitor. Okay, but the the current here, where here, using the function I explained from a minute. Here we multiplied by 100, 1000, sorry, multiplied by 1000, so we can get the output of this equation to be in the current, but in milliampere. Okay, so if we multiply the current and the voltage together, multiplied both of them, we'll get the power, but in milliwatt. Okay, and then I use the LCD to print also the voltage and the current and the power. Okay. Here is the system. The voltage and the current, the power, all of them. If I change it, the voltage of this battery, I made it like 20 volt, 20, 12, sorry. The voltage changed and also the current increased because I increased the voltage and also the power. There is another code I made for the sensor Max 471 here, but this one isn't in the library of Proteus, so I can't test it here. But if you have the hardware itself, you can connect this pin to VT and AT on the sensor of the Max 471, and it's gonna work. I tested on my hardware. And that's it. Thank you.